objects are in this set here? So how many objects are in this set? What? So here's the set, and it has this in it. So how many objects are in the set?
2.
No, so this is the object, right?
Oh, 1.
So there's one set, or it's just one object. It's just this ordered pair here. So if you want the probability of this set, you have just this single object in the set. So this would be 1 divided by however many objects in the sample space. So in this case, it's 1, 2. So there are 4 outcomes here. So if you're using the compound probability function, that's defined as if you want to find the probability of some outcome like this, you find this outcome on the tree diagram. So let's say this outcome you're looking at is HH. You just multiply these probabilities on the branches, and that's the probability of this outcome. For the egalitarian probability, what you do is you count up how many outcomes you have total. So you have here's an outcome, here's an outcome, here's an outcome, here's an outcome. So there are 4 outcomes possible, and then your event here only has 1 outcome in it. So the probability of this event would be the number of objects in that event divided by the total number of outcomes. But in this example here, these 2 functions will be the same, okay? Because these A, B, C, D, and E, and F would all be 1/2, right? So all of these would all be 1/2, okay? So if you wanted the probability of HH, it would be 1/2 times 1/2, and that's 1/4. So that's the same as if you just counted up all the possible outcomes, and then took the number of outcomes in E divided by the number of outcomes in the sample space. Okay. So in these examples, like when you roll, like if you toss a coin twice, or if you roll a die twice, or if you roll a die like 5 times, in all those examples, this compound probability function will turn out to be egalitarian. Okay? It would be the same as if you just use this egalitarian probability function. You guys have any questions on this? So let's do this one. So I want to know for A, so what is the probability that a 7-digit phone number has at least 2 5s. And for B, I want to know what is the probability that a 7-digit phone number has at least 1 7. So repetition is allowed here. Repetition and the leading to 0 are allowed. So I have these 7-digit phone numbers. I want to know what's the probability that a 7-digit phone number will have at least 2 5s, and then I want to figure out what's the probability that a 7-digit phone number will have at least 1 7. So for A, so I want to figure out what's the probability. So first of all, the sample space is a set of all these sequences of like 7 slots, right? So 1, 2, 3, 4, 5, 6, 7. So you have 7 slots here. Okay? This is going to be your 7-digit phone number. So how many total 7-digit phone numbers are there? So I want to figure out how many totally, like how many there are possible of these 7-digit phone numbers. So it'd be 10 to the power 7, so there's 10 here. You can make 10 choices for each slots. So if you multiply all of these, this is 10 to the 7th. It's a 7. That's like a weird. And so now I want to figure out how many 7-digit phone numbers you can form where you have at least 2 5s showing up. Okay. So if you want at least 2 5s, so what you can do is you can take the total number, so this number where we have at least 2 5s, that'll be the total number, minus, so if you want to figure out how many 7-digit phone numbers have at least 2 5s, you take the total number of 7-digit phone numbers, and you throw out all of these 7-digit phone numbers that have fewer than 2 5s showing up. Okay? So you're going to throw out where the phone numbers that have 0 5s, so 0 5s. And you throw out, so exactly, let's say exactly 0. Exactly 0 5s, exactly 1 5, minus exactly no, so that's good enough. So you figure out how many phone numbers there are total. You throw out the number of phone numbers that have 0 5 showing up, and you throw out the number of phone numbers that have exactly 1 5 showing up. And then all the numbers that are left, so once you throw out those two sets, all the phone numbers that are left will have exactly, or they'll have at least 2 5s. You guys see that? So these are the phone numbers that have exactly 0 5. These are the phone numbers that have exactly 1 5. If you take the total number of phone numbers and you throw out these two, then all the numbers that are left will have at least 2 5s. Okay? So we need to figure out how many phone numbers have exactly 0 5s. So for here, so this one is 10 to the 7th. This one here, you want to figure out how many of these phone numbers have exactly 0 5s. Okay? So you take these 7 slots, okay? You choose none of them to put a 5. Okay? And then of the slots that remain, so after you choose 0 of these slots, you're going to fill in the remaining slots with everything except 5. Okay, so you want to only put stuff here that's not a 5. So how many choices do we have for this first slot? 5, and then you'll have 5 choices for each of these, right? So this will be 5 to the 7th. Or is it 9? Sorry. So you'll have, you can put any of the digits here except for 5. So you can put 1, 2, 3, 4, 6, 7, 8, 9, and 0 here. You can do the same thing for each of these. So this will count up how many phone numbers have exactly 0 5s. Now if you want to find how many phone numbers have exactly 1 5, so you take these 7 slots, you choose one of those to put a 5. So you take these 7 slots, you pick one to put a 5 there, and then for the rest of the slots you fill in with any of the digits that are not 5. So then, how many choices do we have for the remaining slots? 9, and this is 6, right? So this would be 6, 7 minus 1, and this would be 7 minus 0. So you can see the pattern. So if you wanted the number of phone numbers that have exactly 2 5s, then you take 7, choose 2, and then you multiply by 9 to the 7 minus 2. So the probability here. So they wanted to know what's the probability if you just pick a random phone number, what's the probability that it has at least 2 5s? So there are this many phone numbers that have at least 2 5s. So you take this thing. It's this. Well, I don't remember what that is. Circle this. And we'll say 10 to the 7th minus this thing minus 0 minus this. So this divided by 10 to the 7th. Okay. So just take the number of phone numbers that have at least 2 5s, and you divide that by the total number of phone numbers. You guys have any questions on part A? So for part B, I want to know what's the probability that that the phone number has at least 1 7. Okay. So I need to figure out how many. I already know how many phone numbers total there are. There's 10 to 7. So that's the total number of phone numbers. Now I need to figure out how many of those phone numbers have at least 1 7. Okay. So you have these 7 slots again. You're going to pick one of them and put a 7. So I guess you can do it like this. You take the total number, and you throw out the ones that have 0 7s. Okay. So you take these 7 slots, you pick the 0 to fill in with 7. 7, 0, and then the remaining slots, there'd be 7 of those. They have 9 choices each. Do you guys have any questions on this one? Let me tell you about conditional probabilities. So, like I said earlier, sometimes you can have a sample space and you can put different probability functions on a sample space. So, normally what you want to do is you want to choose the probability function that reflects reality better. Right? So, if you have a coin and you toss it, 1,000 times, and the coin shows up heads like 80% of the time, then you probably want to use a probability function that reflects that. So you want to use a probability function that will tell you the probability of heads is like 0.8 and the probability of tails is 0.2. Okay. So if you have a probability function and you know that some event has to occur, then you should probably change your probability function. So let me use this thing. This is conditional probability. So let's say that you have P, and this is a probability function. On omega. Okay. So let's just take some event E, or E, be some event in omega. Okay. So let's say this event actually occurred, right? So let's imagine we have a multiple choice problem, right? So there are 4 choices on this multiple choice problem. Okay? And so I ask you, you just guess randomly, okay? And I ask you, what's the probability that you get this correct? So there are 4 choices here, right? You're just going to guess randomly. So what's the probability that you guess correctly? What's it going to be? 1/4, right? So let's say I told you that that the answer is not D.